Hello everybody, in this video we are going to look at our simplifying expression and solving equation notes. This video in particular, we're just going to focus on the academic vocabulary that goes with this section. So the first thing I want to point out is the first definition is an algebraic expression. It is a symbol or combination of symbols containing at least one variable, operation, or number. The most important thing you should know about an algebraic expression is that it doesn't have an equal sign. So in this column right here, we're going to go ahead and add a visual representation of what these vocabulary words represent. So here, I went ahead and wrote an expression. So go ahead and write this one down. And so we're going to actually refer back to this expression to be able to name or give an example of all the other vocabulary terms. Okay. And remember, you can pause this video at every time so you can get yourself caught up or write something down. All right, we're going to go ahead and move on to the next one, which is a term is a number, variable, or product of a number and or variables. And then it says addition and subtraction separates the term. So if you look at this expression up here, we're going to talk about how many terms and what is considered a term. So if you look right here, I'm going to go ahead and point out that we have 4 terms in this expression. This is a term. This is a term. Another one, and another one. So this expression has 4 terms. So I'm just going to write 4 terms. And if you want to draw an arrow so you know what expression we're referring to, where did we get the 4 from? We got it from this expression. And then we're going to name the terms. So one term is 2x, negative 3xy, 5y, and 15. So those are all the terms. So notice that we have a negative, a positive, and a positive. Those symbols actually represent or separate the terms in the expression. All right, the next one we're going to talk about, I'm going to move this up, variable. A variable is a symbol that represents a value or a set of values. In algebra, symbols are typically represented by letters such as X. So this right here is going to be the letter that we use in an expression or an equation. So if you look at our original right here, our original expression, we have an X, we have Y's. So we're just pulling out all the letters. So we're going to say an example of a variable is X and Y. And remember that a variable can be any letter in the alphabet. It can also be a symbol that is not a letter. All right, the next one is coefficient. A coefficient is a number that is multiplied by a variable. So if you look at your expression up here, a coefficient is the number that is attached to the variable or a letter. So if you look up here, we can see that the coefficient is 2. Because 2 has this x. We can see that another coefficient is negative 3 because negative 3 is attached to the x and the y. And our third coefficient is 5 because it's attached to the y. So if you're looking at the 15, the only reason the 15 is not a coefficient is because it doesn't have a letter attached to it. The 15 is just a 15, and we have a different name for that. So let's go ahead and write out the 2, the negative 3, and the 5. All right, so the next word is constant. It's a term in an expression that contains only numbers and is not multiplied by a variable. So when we're looking at our expression and we're looking for coefficients, we had to make sure we're looking at numbers that had a letter attached to it, like the 2, the 3, the 5. And then we said 15 is not a coefficient because it doesn't have a letter. So 15 is actually the number that we use to represent a constant. A constant has no letter attached to it. It's just the plain number. Okay, and the constant can be a positive number, a negative number, a fraction, or a decimal, as long as it doesn't have a letter or a variable attached to it. All right, I'm going to go ahead and move this up so we can look at the next set of vocabulary words. And so right here, our next word, oh, sorry. Our next word is going to be factor. Factor is just another way of multiplication. So it is a number or an expression that is being multiplied by another number or expression. So if we go back to our original expression, and I'm going to go back and forth just because this is the one we're using, we can see that if a number or a letter are next to each other, that implies multiplication. So I'm going to start with the 2x. 2 and x are factors of each other because 2 is being multiplied by x. So there's multiplication involved. All right, if we look at the next one right here, we can see that we have three things. We have a -3, an x, and a y. So we can say that -3, x, and y are factors of each other because there's multiplication happening there. And then the last one that's being multiplied is the 5 and the y. So I'm going to move this up a little bit, and we're going to say 5 and y. Okay? So factors could be two numbers being multiplied together, or we can have a number and an expression, which will come up later on in Algebra 1. But for right now, we're just looking at numbers and letters. Okay. All right, the distributive property, I actually had to make an adjustment here because it has an A, and I told you to change it to the. The distributive property is a mathematical rule that multiplies an outside term by all the terms inside of a parentheses. So in order for the distributive property to take place, we have to have a set of parentheses. And there should be something inside of those parentheses, and there should be something on the outside. So I'm just going to give you an example because our expression that we've been using, we can't use that for the distributive property. So say, for example, I have a -2, open parentheses, 3x minus 4. This would be an example of the distributive property because we have a set of parentheses. We have a number on the outside and numbers on the inside. Now, I gave you two numbers, a small expression, but it could be much bigger than this. It could have 3 or 4 terms. And when we do the distributive property, we take the number that's on the outside with the sign and we multiply it by everything inside. So I would multiply -2 times 3, and then I would multiply -2 times -4. So I'm actually going to write this one out, and I'm going to say -2 times 3x and -2 times -4. And so if we were to clean this up, we know that -2 times 3 gives us a -6x. And if we multiply -2 and -4, we get a +8. So the distributive property is the part where we take the outside number and multiply it by all the numbers on the inside. So we distribute that -2. Okay, so that is the distributive property. All right, another thing that we need to talk about are like terms. So when it comes to adding and subtracting, in Algebra 1, it's really specific. You can't just randomly add and subtract any number. They have to be like terms. And in order for something to be a like term, they have to be terms that contain the exact same variable and is raised to the exact same power. So let's look at a couple things that would be considered like terms. So if you had a 2m, another like term or another number that you can add and subtract to 2m or combine would have to have another m. So I could say that a -3m would be considered a like term because notice that they both have an m and they both don't have exponents on the m. So it has the same letter or variable raised to the same exponent. All right, let's give you another example. Let's say, for example, I have a -4n squared. So my variable is an n, and it's raised to the second power. So if I wanted to find another number to add or subtract, or say it's a like term, it would have to be any number with an n squared. So let's say, for example, 5n squared. So the reason we can say that -4 and 5 are like terms is because they have the same variable, they both have n's, and they're both raised to the second power. All right, the last example we're going to do is, what if I have a number like 5 that has an x and a y? Well, because the 5 has both an x and a y, if I wanted to identify a like term to add or subtract to the 5, I would have to find something else that also has an x and a y. So if I had a -2, it would have to have an x and a y for me to be able to say it's a like term. So as we start working through some of these problems, I am going to ask you to look if they're like terms. Do they have the same variable raised to the same power? All right, so we only have a couple more that we need to look at, so let's go ahead and look at these two together. An equation is a math sentence that uses an equal sign to show that two expressions have the same value. So an expression is just looks like this. Notice it doesn't have an equal sign. So equations have equal signs. So it would look something like 2x plus 5 is equal to 10. So I'm going to circle right here the equal sign. And so that now tells us that we're not just cleaning it up because it is an expression and we're just trying to simplify it. We actually have to solve it until we get one, like x is equal to a number, one specific number. Okay. So equations have equal signs and we have to solve for whatever our variable is. All right, inverse operations right here is a mathematical action that completely reverses or undoes the effect of another operation. So when you hear the word operation in math, we're talking about what we can do to numbers like adding, subtracting, multiplying, and dividing. Some of those operations have opposites. So if I say addition, well, the only way to undo addition is to use subtraction. Notice I use a double-sided arrow because addition also undoes subtraction. It works both ways. So if I use multiplication, then division will undo it. And I'm just going to throw an extra one in here. If you have something raised to the second power, which means it's going to be n squared, the opposite would be to square root it because those are opposites of each other. So I know it took us a while to get through several of those vocabulary words. I gave you some examples of what we need to look at or what is actually considered a representation of these vocabulary words. I'm actually going to pause our video right here. We're going to stop and then we're going to look at some of the practice problems in our notes in a different video. So I hope this helped and then I'll see you guys in the next video.